1.3, last one. It's probably complicated, hey? Well, the first part of it is not. They give you a cheat. So it's kind of for a very specific circumstance, but if you have compound interest and you're looking to double your investment, you can use a really, really simple trick to just kind of estimate how long that's going to take you. Now, what you want to do is, say you've got, I don't know, 3.6% interest. Okay, I'm going to invest $1,000. At 3.6% interest, I want to know how long it's going to take to double. So it actually, I don't care about that, because what I can do with this is the rule of 72. The rule of 72 simply states that you can go 72 divided by 3.6, not the decimal version, but actually the percent version, just like that, and you will get approximately the amount of time that it takes you to double your $1,000 at 3.6. So I go 72 divided by 3.6, and I get 20. So 20 years. That's a long time to double that, but that's a pretty low percentage. So if I had a $1,000 investment that I put in at 3.6% compounded, the details are vague, so they don't really talk about compounded how often per year and that kind of thing. It's just a basic estimate on how long it's going to take you. So it's not going to be exactly 20 years, but it's going to be about 20 years that it takes you to double. All you got to do when they ask you a question about how long does it take to double, only works for doubling, then you're just going to use this. 72 divided by the interest rate gives you the approximate time. Pretty simple, right? Now, we're just going to go and we're going to put over here 72 over 3.6 equals 20. And that's using the rule of 72 to figure it out. So the reason why I'm doing that is because I'm going to use this example to go through the next part, which is where it gets a little more complicated. So that only works for doubling. If I wanted to find out how long it took to triple, or how long it took, or basically how much money I was going to make over a 2 or 5 year time span, those are all very, very different questions. I can't use the rule of 72. So the rule of 72 is nice and simple, but it only works when you're finding out how long it's going to take for something to double. So it's nice, but it's limited. What we do otherwise is we're going to use a formula. Your book has irritating formula, so I'm going to give you the one that I like to use. And that is that A, which is all of it, equals P times 1 plus your rate of interest over the number of times compounded to the power of n times t. Now, that might look a little bit freaky, but you just put this stuff in and solve this stuff and keep solving it out. It's not a really big deal. What we're going to do right now is just go over what each one of these things mean. So this is all the money. All the money. If I invest $1,000 and I leave it in for 20 years, then I should get $2,000 here, which means that my total is $2,000. Now, let's change the color up a bit. P is your principal, same as before. Whoops, not principal. So that's going to be the money that you invest. 1 stays the same, it's just 1. Let's see, use this one again. That's your rate of interest. And it has to be a decimal, same as before. Now, n's kind of a different little monster. N is the number of times it's compounded per year. So we're going to do a little n chart over here. If it's compounded yearly, n equals 1, because you're just making 1 yearly compounding. If it's semi-annually, or this could be annually too, If it's semi-annually, then that's 2 times a year, so we make it 2. If it's monthly, then that would be 12. If it's, I think they call it bi-monthly, that would be 6, because that's every 2 months. That's what bi-monthly means. Weekly would give you 52, because there's 52 weeks in a year, and daily is the other one, which is a little crazy, because it's 365, because there's 365 days in a year. Now that's the number that's going to go in here. So when you, oh, there's one more, quarterly. Hopefully I've got enough space on here. Quarterly means 4 times a year. It's every 3 months. They like that one. They use it a lot. Right, so that's your value for n that's going to go in here. Also in here. And t, being the last one, is simply the number of years. Now, you could plug all that in and work out the answer, but there's another cheat that we're going to use on your calculator, so relax for a minute. I'll go through an example with you for this one. Just know in the back of your mind that you don't actually have to use this if you have a graphing calculator. All right, so we're going to use the same numbers. We're going to use that 20. We're going to find out what do we actually get after the 20 years. So we're going to figure out whether it's close to 2,000 or not. So we're going to use 1,000 as our principal. This is our P. And our rate is here. This is our R. We're going to make up, well, let's use quarterly. They love quarterly, so we're going to use quarterly for n, so n's going to be 4. And what else do we need? Time. Time in years is supposed to be 20. So that's 20. We're going to put this all together. I'm going to make myself a little bit of space here, though. So right underneath of this one, I'm just going to fill in all the answers. I want to know what it takes for $1,000 to go at a rate of, oops, not 3.6, 0.036, because I'm going to divide that by 100, over n is 4 to the power of 4 times 20. Now, the best way to go about this is to do it in steps. So 1,000, I would go in my calculator and divide 0.036 divided by 4 gets me 0.009, so this is 1.009. I solve this by itself, and then 4 times 20 is to the power of 80. So that's a much simpler thing to solve. I'm just going to solve that to the power of 80, so 1.009 to the power of 80. Sounds like a big number, but it's just 1, so not a big deal. And then I'm going to multiply that by 1,000. And when I get my answer, it ends up being 2,047.83. So pretty close to exactly 20 years, because we said that it would be 20 years for it to double to 2,000, and if we work it out using this formula, it ends up being 2,047.83. It's a bit of extra change. If you don't like this, tune in to the next video, because I'm going to show you how to use your graphing calculator to cheat.